Welcome to this guide on cloud design patterns. In this video, we'll explore common architecture solutions that help you build better cloud applications. Cloud design patterns are essential tools for anyone working with modern cloud infrastructure, whether you're using Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Cloud design patterns are reusable solutions to common problems that occur in cloud architecture. Think of them as proven approaches for building applications that can scale effectively, remain reliable under stress, and perform well. These patterns are platform agnostic, meaning the principles apply across all major cloud providers. They represent best practices learned from real-world cloud implementations by thousands of organizations. Instead of reinventing the wheel, you can apply these tested solutions to your own architecture challenges. Let's start with scalability patterns, which help your applications handle growing workloads. Auto-scaling automatically adjusts your computing resources based on demand metrics like CPU usage or request count. Load balancing distributes incoming traffic across multiple instances to prevent any single server from becoming a bottleneck. Queue-based patterns decouple your components using message queues, allowing asynchronous processing that smooths out traffic spikes. Finally, Content Delivery Network caching stores static content at edge locations around the world, bringing data closer to your end users for faster access. Reliability patterns ensure your applications stay available even when things go wrong. The Retry pattern automatically retries failed operations using exponential backoff strategies, giving temporary issues time to resolve. Circuit Breaker prevents cascading failures by stopping calls to services that are already failing, similar to an electrical circuit breaker. The Bulkhead pattern isolates resources into separate pools, so if one component fails, it doesn't bring down your entire system. Health Endpoint monitoring continuously checks service health through exposed endpoints, allowing early detection of problems. Data management patterns optimize how you store and access information. Command Query Responsibility Segregation, or CQRS, separates read and write operations using distinct interfaces, allowing you to optimize each independently. Event sourcing stores state changes as an immutable sequence of events rather than just the current state, providing a complete audit trail. Sharding partitions your data across multiple databases for horizontal scaling, distributing the load. Cache-aside loads data into cache on demand, improving read performance by reducing database hits. Messaging patterns facilitate communication between distributed components. Publish-subscribe, or pub-sub, allows publishers to send messages to topics, while subscribers receive only the messages relevant to them. Competing consumers enables multiple consumers to process messages from the same queue, distributing the workload. Priority queue ensures high-priority messages get processed before lower-priority ones, which is critical for time-sensitive operations. The claim check pattern handles large payloads by storing them separately and passing only references in messages, keeping your message bus lightweight. Security patterns protect your applications and data. Gateway aggregation provides a single entry point that aggregates multiple backend service requests, reducing the attack surface. Valet key provides clients with limited access tokens for direct resource access, eliminating the need to route everything through your servers. The Gatekeeper pattern uses a dedicated broker instance to validate and sanitize all incoming requests. Federated identity delegates authentication to external identity providers like Google or Microsoft, simplifying user management while enhancing security. Performance patterns optimize how efficiently your system operates. Throttling controls resource consumption by limiting request rates, preventing any single user or service from overwhelming your system. Materialized view pre-generates views with aggregated data, so complex queries can be answered quickly without expensive calculations. Static content hosting serves assets directly from cloud storage rather than through application servers, reducing latency and server load. Index table creates indexes on frequently queried fields, dramatically speeding up data lookups. Deployment patterns help you release changes safely and efficiently. Blue-green deployment maintains two identical production environments, letting you switch traffic instantly with zero downtime. Canary release gradually rolls out changes to a small subset of users first, allowing you to catch issues before they affect everyone. The Sidecar pattern deploys helper components alongside your main application container, handling cross-cutting concerns like logging or monitoring. Ambassador offloads networking tasks to a proxy container, simplifying connectivity between services. The Strangler Fig Pattern helps you incrementally migrate legacy systems to modern architectures without a risky Big Bang rewrite. Named after a type of tree that gradually grows around and replaces its host, this pattern works in 3 phases. First, you route new features to modern services while keeping the legacy system intact. Second, you gradually replace old functionality piece by piece, migrating users incrementally. Finally, you decommission legacy components once they've been fully replaced. This approach minimizes risk and allows continuous delivery throughout the migration. Knowing when to apply each pattern is crucial. For traffic spikes, combine auto-scaling with load balancing to handle sudden increases in demand. When dealing with service failures, use circuit breaker together with retry pattern to prevent cascading issues while giving services time to recover. For complex queries, implement CQRS with cache aside to optimize both read and write operations. When you need decoupled services, PubSub combined with event sourcing provides flexible, scalable communication. And for legacy migration, the Strangler Fig Pattern offers a safe, incremental path forward. Let's recap the key points. Design patterns solve recurring cloud architecture challenges that teams face every day. You'll often combine multiple patterns to create comprehensive solutions tailored to your specific needs. Choose patterns based on your particular requirements and constraints, not because they're popular or trendy. Well-architected systems balance scalability, reliability, and cost, making trade-offs where necessary. By mastering these patterns, you'll be well-equipped to build resilient cloud architectures that can grow with your business. Thanks for watching, and happy architecting.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.